Today I would like to go over the forms for which we use to express derivatives. The first being Lagrange's notation. And we have our function right here, f of x being equal to 3x squared plus 7, taken on the example for ways to express the derivative for f of x. So Lagrange's notation is much more commonly used in these rudimentary levels of calculus, dealing with single variable calculus, which is f of x prime. The prime of a function represents Lagrange's notation, which also represents the derivative of a specific function. So to evaluate this f of x's derivative in Lagrange's notation, the f of x prime will be equal to 3x squared plus 7 primed. And all of these little dashes is just signifying the derivative, and it's called a prime. So this can then be evaluated with the power rule as 6x. So this is how we evaluate derivatives and represent derivatives through Lagrange's notation, which is through the form of a little dash on the upper right hand side of a function, other known as the prime. In Leibniz's notation, where it's kind of confusing to understand and difficult to manage in single variable calculus, but will get especially useful in multivariable calculus. So that is the d of f of x over the d of x. And all this is telling us is this d symbol right here. D is only simplifying it to be the derivative. That's all it's telling us. D represents the derivative. And this f of x that goes next to a derivative in the numerator means the function for which we wish to find the derivative in, and the denominator d of x represents which variable we are finding the derivative for. So for this specific example, d of f of x divided by d of x, what it's trying to say is we want to find the derivative of x within the function of f of x. So this will be equal to d over dx if I put the function right here, 3x squared plus 7, which is equal to, with the power rule, 6x. And finally, we have Newton's notation, which is much more commonly seen within physics and science mathematics, where the derivative is applied in real life scenarios. And the way Newton represents it is with a dot. So what I mean by this is if I have f of x, a dot right on top will signify the derivative. So f of x with a dot on top means the derivative in terms of Newton's notation, which is equal to 3x squared plus 7 with a dot on top, which is then equal to 6x by the usage of the power rule. So there we have the three notations for which we use to express derivatives in calculus.